did I just turn off? So today we're talking about converse theorems. This is working in the opposite order we were working in before. My essential question is... Where's my blue pen? That's not my essential question. My essential question is, how do you prove lines are parallel? So before we knew the lines are parallel, this time we're working backwards. Why do I write so big? Converse is a statement that is created by switching the if and then statements from a theorem. Yeah, just a number. And then it's gonna mark you off for 7 points for number 1 because I figured that by now. So. Thank you. Okay. So the alternate interior angles converse is if alternate interior angles are congruent, then the lines are parallel. Then I have the consecutive interior angles. This is if consecutive interior angles are supplementary, then the lines are parallel. then I have alternate exterior angles converse. If alternate exterior angles are congruent, then the lines are parallel. Okay, then I have consecutive exterior angles converse. This is if consecutive exterior angles are supplementary, then the lines are parallel. Okay, the corresponding angles converse states that if corresponding angles are congruent, then the lines are parallel. Okay, so this one wants me to prove that alternate interior angles converse, given that alternate interior angles are congruent. So what are a pair of alternate interior angles that you guys want me to pick? What? 4 and 6. Okay. So I'm going to use angles 4 and 6. So I'm going to start with angle 4 is congruent to angle 6, and this was given to me. Okay. So what I'm trying to prove is R is parallel to S. So what do I know? What kinds of things do we talk about up at the top of the page that I can use? I can't use the alternate interior converse because I can't use what I'm trying to prove. But then I have to get to exterior angles. So, thinking back to what we just talked about, I can use corresponding angles, I just need to get there. Okay? So I am going to say, alright, I always use red second. I'm going to pick angle 2 is congruent to angle 4. How would those two be congruent? They're not linear. They're vertical. So this is the vertical angles theorem. Why am I not? Okay. Then what can I say? What would I normally do in the other proofs? What would be the next step? So notice I have angle 4 up here and angle 4 down here. It's not called substitution, it's called different word. Same idea though. I'm linking them together like cars on a train. No. Transitive property. Why does that Y look so ugly? Okay. So now I have, that was green. So now I have these two together. Do I have anything up above that talks about those kinds of angle pairs? Trade in, be quiet. So do I have anything up here that talks about the relationship between angles 2 and 6? Okay. Anything out of these 5? The corresponding angle is converse. So I'm going to say R is parallel to S by the corresponding angles converse. And then I end my proof with, therefore R is parallel to S. Can I move on to the back or not yet? Okay. So this one wants me to prove consecutive exterior angles converse. So what is a pair of exterior angles? Two and 7. So I'm going to start off by saying angle 2 and angle 7 are supplementary. How do I know that? So it was given to me. And then I'm also trying to again prove R is parallel to S. So where's my yellow? Actually, let's use purple. What's special about 2 and 3? They're a linear pair. So okay, and this is by the definition of linear pair. Okay. Then angles 2 and angle 3 are supplementary. And this is by the linear pair postulate. So then I'm going to say angle 2 plus angle 7 equals 180, and we'll do this one in purple. Angle 2 plus angle 3 equals 180, because these are the definition of supplementary. Then I'm going to say angle 2 plus angle 7 equals angle 2 plus angle 3 by the transitive property. Then I'm going to have angle 7 equals angle 3. This was just by subtracting angle 7. Then I'm going to have angle 7 is congruent to angle 3. And this is the definition of congruent. Then I'm going to have R is parallel to S, and this is going to be by the CAC, the consecutive angles converse. Therefore, R is parallel to S.